We are now going to go over the formulas for the chain rule and walk through some examples. The chain rule is just a formula for finding the derivative of a composite function. There are two variations of this formula that we are going to be going over. In both variations, our composite function is written as f of g of x. In the first variation, function notation is used, and the derivative f prime of x is written as the derivative of the outside function times the derivative of the inside function. In many problems, the function f of g of x is the function g of x raised to the nth power. So I went ahead and I wrote down the derivative. The derivative for this type of a function is the derivative of the outside function, n times g of x to the n minus 1, times the derivative of the inside function, g prime of x. You want to use these formulas once you're comfortable with the chain rule and you want a quick way to find the derivative. In the second variation, down here in this green box on the bottom, Leibniz notation is used, and u is assigned to be the inner function g of x, and then y is equal to f of u, and that's the outer function. The derivative dy dx is then written as the derivative of y with respect to u, that's the derivative of the outside function, times du dx, which is the derivative of the inside function. I would suggest using the second formula when you are first learning the chain rule. It just makes it a little bit easier. And then when the inside function is really complicated. When you use either of these formulas, all you're going to do is take the derivative of the outside function and then multiply it by the derivative of the inside function. Let's now walk through two examples so that I can show you how to use each formula. In both of these examples, we are going to differentiate the function using the chain rule. Let's look at our first example. Our function is y is equal to the quantity 2x cubed plus 5 raised to the 4th power. For this problem, I am going to use the formula that uses Leibniz notation, and we're going to begin by setting u equal to the inside function, and that is 2x cubed plus 5. And then y is equal to just u to the 4th. We just plug in what u is. Now let's write down our formula. We want to find the derivative of y with respect to x, and that's going to be derivative of y with respect to u times the derivative of u with respect to x. This gives us dy dx is dy du. dy du is just the derivative of this function, and that's going to be 4u cubed. And then du dx is just the derivative of that function, and that is going to be 2 times 3 times x squared. You just subtract 1 from the power. Let's now simplify our answer. We have 4 times 2 times 3, so that's 8 times 3, which is 24. And then we have an x squared. And then for u, we are going to substitute in that u is 2x cubed plus 5 raised to the 3rd power, because our answer has to be all in terms of x. Let's now look at our second example. In this example, we have the function capital F of x is the quantity 2x cubed plus 5 raised to the 4th. So it's the same function that we just worked with, but now for the chain rule, we are going to use the function notation. All we're going to do is set capital F of x equal to f of g of x. Capital F prime of x is the derivative of the outside function f prime of g of x times the derivative of the inside function g prime of x. Once you get used to this, you won't need to write down this formula. Now let's go ahead and find capital F prime of x. It is the derivative of the outside function. So this is 4 times 2x cubed plus 5 raised to the third power times the derivative of the inside function, which is just this part of the function. And that derivative is 2 times 3x squared. Now all we have to do is combine everything. Our constants, we have a 4 times 2 times 3, so that's 8 times 3. That gives us 24. And then we have an x squared, and then a 2x cubed plus 5 raised to the third power. And that's our final answer.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.